Okay, so it's moment of truth time. Where is the vowel A in the vowel space? I've loaded up Bruce Hayes's production of Hade here.
Hade.
And remember, A in English is usually a diphthong. We can just kind of extract that part of it here.
Hade. Hade.
And if you can't hear that, maybe you can see it a little bit better. We have a different vowel quality here than we have at the tail end. It's a little bit higher in front or at the end, right? So I'm going to grab formant measurements out of this first sequence. So I'm going to get my F1 to be about there. That's about the middle. I'm going to point out as I do this that if you're having trouble doing this, a trick you can use, or having trouble figuring out where the formant values are supposed to be, a trick you can use in Prot, which may or may not be helpful, is to turn on the Formant Tracker. So just go up to Formant up here at the top of the sound window and then say show formants. And it gives you these lines where it thinks the formants are. So it doesn't really work well for things that are not voiced or periodic, like the H at the beginning of the vowel. And maybe it's marginally useful for things like the stop after the vowel. But it more or less is trying to track where it thinks the vowel formant midpoint, the formant midpoints are for each of the formants in the vowel. And at this point, we're relatively close. So we're at 466.9 for an A. Sorry. And then I'm actually going to turn it off because it's a little bit easier for me to just see it if I look at it myself. I've seen enough of these in life. So the thing I'll mention, the second formant is about 2130 for this particular vowel. The thing I'll mention is the formant tracker is not as reliable as, say, like the pitch tracker is for Prot. The pitch tracker is actually pretty good. The formant tracker sometimes just makes wild guesses, and so you still have to like look at this and kind of verify that it's doing something that's meaningful. Usually you can see the formant values a little bit better than the formant tracker can, but it can help you get started if you're not used to this. At any rate, we're at 466.9 and 2130. I don't know what you guys guessed, if you guessed about this, but I'll plot this on the board. I think I'll do it in green. So we're about there. Hopefully I'm not taking too many liberties with that. It's in green, so it's a thicker marker, and it's nicely finely detailed, but there it is. It's kind of where we'd expect it to be based on what we know about the vowel space. In fact, that's such a mess. I'm just going to get rid of it and draw it with this little mini marker. Yay. I still have terrible handwriting even though I'm working at home. But there it is. It's A in green. Hopefully that's where you expected it to be. I'm going to end up this video with a couple of questions for you all. So go back to the slides and remind us of where these things are coming from. So resonant frequencies are primarily based on the length of the speaker's vocal tract, the length of the open tube. So the longer the vocal tract, the lower the formant frequencies. Remember, resonance is based on how long it takes to go from like the source of the sound to the bounce and then back again where you reinforce it. So the longer that vocal tract is, assuming the speed of sound is just constant, the longer that vocal tract is, the longer it's going to take to repeat that pattern, right? And then the lower the frequency is going to be because you're not pushing as often. So thought question number one, since I'm posting this on YouTube for the whole world to see, potentially, I'm going to hedge this one a little bit, but just say, what effect do you think lip rounding might have on formant frequencies? And question number two is, how might formant frequencies differ between men and women? Think about those two questions. We'll answer them in the next episode.